Hello, I'm Verder Busto, and this is the Schumann Resonance Harmonics channel on YouTube and on Facebook. Thank you for joining me here. It's still the 30th of January, and this is part 2 of the video that is based on the research paper, Prediction Capabilities of VLF/LF, or very low frequency emissions, as the main precursor of earthquakes, by Kachakhidze, or however that would be properly pronounced. All right, so that they're out of first called Georgian University. Okay, and so once again, I got this as an email. Part of a subscription service I have to academia.edu, and I got updated on all kinds of even remotely related material, such as this, can be extremely relevant as we look at the recent behavior of the seismo from Cumiana. And so this is what we're going to be discussing in part 2, is the relationship between your visual example and our written material, which has absolutely no pictures in it whatsoever. So I thought, how am I on earth am I going to make a video with material that has no pictures in it at all? Well, here you go. This is what we're going to do. So Cumiana has great visual graphics of the latest reading, the amplitude readings in that geographical area. Okay, so we're going to, in this discussion, we're going to look at this at a little more depth than we did last time. And let me kind of bring this up to 100%. Okay. Alrighty. There we go. Okay, let me adjust it over here. Alrighty. Lovely. Actually, hold on. Alrighty, there we go. Okay, so this just be really kind of brief even on this, the close-up. You see the time is on the, where are we? Time is on the 21st. Let me get my brush here, and a color, gonna be yellow, just in case. All right, so our time here is the 20, well, the date is the 30th, right here. The time is 22, that was horrible. All right, so the time is at 22:30. All right, and so, hold on. There we go. All right, so this is right here, our decibel reading chart, once again, okay? And so we're looking at this. This here is, 1,000, and this here is 100. All right. So you see that they're not that big, they're not that significant relative to what we have seen before, okay? All right. And yet these spikes up here, that goes up to about 2, 4, 6, 7. And remember, this is negative. Sorry about that. The thing just slipped. Remember, this is negative. Okay, so even though it's negative 70 decibels, all right, and so you can't really see it behind
Oh, there we go. All right, so it's negative 70. Got all messed up here. Sorry. Negative 70 decibels. I'm sorry. It's 700. All right. I'm sorry. It's not 70, 700. So the peak of this is at about 700, 700. And so this goes up to 1500. All right, 1.5. Okay, so remember that. I got to remember the camera. You guys are looking at me over there. All right, so I'm just pointing these out. Okay, so these are the highlights of it. Now, something else is, you noticed it's got this undulating, rolling pattern, right? This is important because this is the meter that's used for detecting earthquakes. And so you're looking at this wave, the sine wave, that kind of builds and builds and builds. And even here, you can see it. It's another sine wave as well. All right? All right, so we're looking at this, the seismic monitor. All right, seismograph. So this is 15. Oh, come on. Oh, sorry. And this here is 30. I need to get one of those pencils that I can write with. All right, so it's showing in this range, and you have to remember the hertz is horizontal. Okay, hertz is horizontal. Come on, just work. It's a new, this is a new board. It's a new desk surface that I'm using. So I'm not used to using it on this. And so it's coming out all garbled when I use the mouse. So I want to kind of make sure it actually is written what it's supposed to be written. So I'm getting frustrated at this thing. All right. So you can see the varying patterns that are developing in there. In the seismogram, hello. All right, where the heck is my mouse here? Right there. So you see these interesting patterns that are going on along there. All right. So this caps at 105 right here, and you see those peaks are a little bit more than that, but there's this pattern, a wave, an undulating wave, as it were. Right. So you see it's an interesting wave. I have to figure this out. All right. So that's something I wanted to point out that is symptomatic of pressure waves with earthquakes. Okay. All right. So you'll also notice these, I have pointed this out before, that these are roughly at the same time every day, which is kind of interesting to me. There's these string of them. Here's one. Here's two. There's another one. Oh, stop it already. Then here's one. And here's one. All right, so I had just point that out. I don't have an explanation for that. It's still, I'm interested to see. I'm just giving it some consideration. I'm not sure what that is. It's interesting to note that there's those kind of little peaks there. Like I said, roughly the same time every day. You can see it. It's interesting. Okay, so that's a. Okay, what it says here is, I've read this before, channel 1 Okay, I'm reading this here. Channel 1, seismic monogram monitor, frequency range 1 to 30 hertz for the top spectrogram. That's this one right here. Signal is coming from geophone IO sensor, Netherlands BV model SN 4-8U, right. 40 decibel amplified with a low noise amplifier. Okay. Channel 2 is electric field frequency range 1 to 105 hertz for the bottom one. Signal coming from Marconi antenna. So you see that. Okay, there's our bottom one. All right. All right. Just undoing some of these things here. Now that they're in this here. Okay. All right, so on that note, what I'm going to do is get the screen ready with the actual material. All right, so, okay, we're back. All right, so here is our material, or the beginning of our material. We covered the abstract in the last video. The intro to the intro is basically the abstract. So this is just the start of it. So first, let me just say this. I realize I should go back and edit all of my videos and cut out some of the blank spots and the brain farts or the me losing stuff or whatever. And I try to pause while I'm doing it. Sometimes I don't. It's just a pain in the neck to do that. I'm like, I'll figure it out on the run. So I don't edit my videos, even though I have the equipment and the means to do it, the software, because quite honestly, it's going to take me time that I don't have toward doing that, and it's going to keep me away from doing other things that are kind of more important. So I try to use the pause button while I'm doing this and make a premeditative, what's the word, preemptive, a preemptive edit with the pause button, so I don't have to do it, or I wouldn't do it anyway, but theoretically, so that I don't have to do it in post edit. So sometimes I'm just tired or lazy, or it's just I can't find it, and whatever. So I would just ask your indulgence on that, because it's kind of makes it a little more fun to just let it go and whatever. All right, it's me, and the other reason is it's me. If I'm on my P's and Q's and I'm doing well, I will hit the pause judiciously. However, some days I'm kind of pause shy, and it goes how it goes. If I have a headache or whatever, like today I have a headache, and so I'm kind of working through that. It's also Mercury retrograde, so I'm just a little bit on the sloppy side of making these, and I ask you to bear with me because this is who I am. And I guess the last kind of thing of it as well is that, it gives a bit of rawness to this otherwise highly technical data, and it kind of adds, my kind of shuffling around and bobble-headedness in doing these, I believe, is a comic, backdrop against this serious stuff, and kind of my humble view of doing this. All right, so being that as it may or may not be true. All right, so we're talking about predictive capabilities of VLF and LF emissions as a precursor, the main precursor to earthquakes, by Kachakhidze and Kachakhidze. All right, so I went through the abstract already, and let me just say this: this abstract was easy to follow. All right, when I do these, just I think a little word of my process to doing these, because any of you who've been around long enough know that I've presented a number of these papers to you for your submission, with the abstract and the introduction, and then the
discussion and the main course and all of that, for your submitted for your approval to do as you see fit. Hopefully you'll learn something from it. Hopefully you can use it, in your discussions with people. Even if not, still, any of you who have been here long enough know that when I do this, I present this from me having gone through the material first. I've read through it, and sometimes I've just briefly gone through it. I've blah, 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 and this will be the first in-depth time. So I've already read through the abstract on all of these, and some of them the only thing I can get is the abstract. But I will say this as a general rule of my guiding principle. When I'm looking for material for the class, you all, that's fairly easy for me to explain, I look at the abstract and I gauge the rest of it based on the abstract. So if there's not a lot of math and not a lot of equations and they present it, it's fairly straightforward and it's not long and not involved, like, okay, chances are the paper will follow suit, that it's not going to be too much math and it's not going to be too much. In a number of papers, when they give the abstract, they start writing on the equations and blah, 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 blah. That's what that's for. That's what it's about, is it to give you the nuts and bolts of what they're doing in it. So if the abstract doesn't have much hardcore technical stuff, you look at this and it's like, oh, all right. And again, they ended it with harmonious. Like, oh, okay, how could you not want to go on from that? All right. So I think I've mentioned this before, but I'll mention it to you as well, for those of you who are into this kind of thing, that you can judge or just beginning to get into it, and you may not have thought of any of these before, having seen mine. I know Wages reads technical journals, but he doesn't do what I do. And this is my place to talk about in-depth articles or in-depth discussions and issues and concepts related to the Schumann resonances and directly related phenomena, and that would be the earthquakes, whereas especially where people are looking for information on the Schumann resonances, and they're going to the VLF and other likewise stations, and they are getting VLF readings and confusing them as Schumann resonances and so on and so forth, blase, blase B, blase C. It becomes time that the Schumann resonances guy kind of steps in and volunteers to offer a little bit of light on the subject matter. And so that's what this is doing. So we're talking about the relationship between VLF energy, VLF waves, and earthquake behavior. So, let me pause this here. Where are we? Hello. I'm going to pause this here for a second, if I can find the button. There we go.
Okay, this is it. This is the main event. All right. Thank you all for being here. I appreciate you coming to support me, to support this channel. Like, share, comment, subscribe, and make sure to hit the little button, the little bell next to subscribed to get all of the notifications. Okay. Within the last decades, many extremely interesting papers were dedicated to various geophysical phenomena. Oh, hello. Revealed in earthquake preparation period. Well, let me start this again. Within the last decades, many extremely interesting papers were dedicated to various geophysical phenomena revealed in earthquake preparation period and after earthquake periods, inclusive the study of Earth emissions in the period that preceded earthquake. Oh, good golly. Authors of the studies emphasize, let's just do one thing at a time, emphasize that Genesis
that genesis of all these phenomena, okay, and they're going to put in the following phenomena: changing of intensity of electro-telluric, electro-telluric current in focal area, perturbations of geomagnetic field in forms of irregular pulsation or regular short period pulsations, very low frequency VLF electromagnetic emission is observed on the Earth's surface. Perturbations of atmospheric electric field, irregular changing of characteristic parameters of the lower ionosphere, and that's plasma frequency, electron concentration, height of D layer, etc. Irregular perturbations reach the upper ionosphere, namely F2 layer, for 2 to 3 days before the earthquake. There are appeared geomagnetic pulsations, and that's 0.022 to 0.1 hertz in several hours or tenths of minutes before earthquakes. Intensity of electromagnetic emission increases in upper ionosphere in several hours or tenths of minutes before earthquake, and sometimes it causes lightning. And their presence in definite period is associated with the earthquake preparation process, although mechanisms of their origin can't be defined yet clearly. Okay, so it's all in English, but it's kind of tough going. All right, so it is known that earthquake prediction implies preliminary defining of the incoming earthquake place, time, and magnitude simultaneously. Today, as with this in view, we meet rather diverse and interesting papers which are published in the world on the basis of ground-based and satellite data of Earth EMF emission observed in earthquake preparation period. And there's a name of, I'm not going to say the names here, the bunch of, these are all the reports that, the data he's going by. Okay, so that's the names of all these people. You'll have to kind of read it yourself, I think, or go there and check it out yourself. All right, so if we had network of electromagnetic emission before earthquakes, we would be able, by means of satellite observations, to differentiate the projection on the ground surface of the perturbed zone in the atmosphere ionosphere boundary that approximately coincides with a zone of precursory activity. Okay? This is evidenced by the results of studies connected by the earthquake of Italy occurring in 2009, according to the opinion of the authors. In case of having of Earth electromagnetic emission network, it is possible to determine 2 to 8 days prior to earthquake by a definite precision the place of an incoming earthquake. It is also interesting that recorded anomalous magnetic field variations, the anomalous ULF signals, were always detected in an area close to the epicenter, about 2 weeks or several hours close to the earthquakes. Okay, this is really interesting here. I agree. It is interesting that recorded anomalous magnetic field variations. Oh, why do you do that there, buddy? Oh, come on. All right, never mind. Recorded anomalous magnetic field variations. The anomalous ULF signals were always detected in an area close to the epicenter for, about 2 weeks or several hours before earthquakes. Okay? Studying geodynamic processes, the authors, this is Morrow et al. 2004, pay special attention to electromagnetic field. To characterize the field, they introduced the notion of telluric tensor, the components of which depend on frequency of field changing, conductivity distribution in Earth, and orientation of coordinate axes. It appeared that maximum value of telluric parameter was fixed on the direction of the azimuth of which was 150 degrees. That is, crosswise of seismofocal zone. Okay, I'm not sure what that is, but as they're talking about, seismofocal is the location of how close to the earthquake it is. All right. At the same time, the occurrence of large earthquakes, magnitude 7.7 and magnitude 6.9, their values decrease markedly. Decrease compared to background values begins approximately 1.5 months before earthquake, and after earthquake, this parameter returns back to its value in approximately the same time. Okay? Some days before large earthquake, in the lower ionosphere, there is confirmed an abnormal TEC, which is total electron count variation above the epicenter. Authors of the present paper have explained the mechanism of Earth EM emission in the period of earthquake preparation by analogous model of lithosphere, atmosphere, ionosphere, LAI systems, self-generated electromagnetic oscillations based on the classic electrodynamics, Kachakhidze in 2011. The physical analogy with the hypothetic ideal electromagnetic contour, the formation of which is assumed in epicenter area of incoming earthquake due to Earth surface electric polarity. Changing is used. In this case, the emphasis is made on the electromagnetic induction effect in local area of the space and not on the physical mechanism conditioning changing of Earth potential value. And in parentheses, atmospheric electric field tension inversion. End parenth. The presence of such effect is proved in the papers, and it's 2009 by Blyer and F. Taxis et al. Alongside with it, due to the fact that electromagnetic emission disturbance is conditioned by thermo-ionized channel and earthquake focus, it might well be that Earth electromagnetic emission is of sector spreading, which, to a definite extent, refers to the main fault direction and epicenter area of incoming earthquake, which is also fixed by observations. And that's Veritsos in 1991, 99, 2000, 2004. All right. So that's at this point, that's the end of it, this lesson, this discussion. So the next one, as you can see, I'm just scrolling ahead. I'm done, but I'm scrolling ahead. So the next one, it's got a little equation there. Not too much, bunch of references. Another equation there. Okay. This is where it starts getting into, a lot of the actual hardcore material, as you can see. All right. So that's going to be at another time. I just wanted to kind of scroll ahead so you could see what we're looking at. All right. So this ends the thing. So I don't know if I'm doing this as a premiere or I'm going to play this live or whatever, but this is the end of the introduction here, and this is a good place to kind of just wish you a good rest of your night. If I don't talk to you in a live stream soon, have a great rest of your night, and I will keep you in my prayers. Those of you who are kind of support me, and that remember me, I will keep you in my prayers. And so there's a handful of you. Thank you all for being here, and I very much appreciate your love and support, and your continued being here. Thank you very much. I could not or would not be able to do this without you, and I'm not kidding. There's about 10 of you, the terrific 10, and it kind of, morphs between different people. Different people are in the middle of that 10 at any given time. But you all get me out of bed. I don't know how to tell you this. I wasn't going to get out of bed this morning, but just my guide said, your people, your group, your family, you got to give them some hope and support. Otherwise, they're if you're not doing well, they're certainly not doing well. So you got to show up ready to give them some support. So, all right. So on that cheery note, that's what I'm kind of doing right now. Is I'm giving you some motivation and support in the same way that you motivate and support me. Thank you all very much. I appreciate you coming here. You're wonderful. Have a great rest of your day. Thank you. Namaste.